Okay, I think it's working. Hello, friends in Antarctica. My name is Dave Young. I'm one of the Wilderness Fellows at the University of Colorado, here for the second installment of Ice Rounds. The last week, which was dive medicine, ran a little bit long. This week should be a bit shorter, but it doesn't mean the topic is any less important. What we're going to talk about this month, is climate change and environmental health. It's a very important part of learning a wilderness medicine curriculum. It's a bit different because we're not going to talk about different practical skills or necessarily wilderness specific disease states, but it's very important for the wilderness provider to be abreast on information about climate change and environmental health, as is really any physician. Why don't we just go ahead and get started. Let's make sure this works. There we go. Sorry about this panel here. I wasn't able to get rid of it. I will not use Keynote in the future. As much as I love Apple products, I just couldn't figure this one out, how to get rid of that. So just a quick little information about me. My email here, feel free to get a hold of me anytime. My email is daveyoung222@gmail.com. Let's do a quick overview. We're going to talk about global warming and climate change, the two most important things that affect human health, besides the overarching problems because of global warming, are extreme heat events and extreme weather events. Those things may be affecting us the most. We're going to talk about vector spread, mostly about mosquitoes there, ozone depletion, water pollution, viruses, bacteria, and parasites that may be traveling in the water and cause infections, as well as toxins. And then lastly, air and soil pollution. I thought this was funny when I was coming across making this presentation. I saw this in some of the Google images, and I thought it was pretty funny. And so there's some little underwear. Paul Auerbach, one of our grandfathers of wilderness medicine, wrote this in a JAMA article in 2008. The medical profession has responded to adverse situations of global reach, such as epidemic disease and natural disasters. As the world's scientists, governments, and businesses now confront the state of the environment, physicians, and I'll change this to health professionals, must also be prepared to respond. So let's talk about global warming, the first and most important thing to talk about. The IPCC, which is the Intergovernmental Panel on Climate Change, state that this is an unequivocal fact. Really, any scientific body of any merit will report that global warming is an unequivocal fact. Human activity is likely a major contributor. There's really no explanation that anyone else can find that can explain why things are changing so quickly, other than the fact that there's been a large change in the human population as well as the resource utilization. Just in the last 50 years, they've been the hottest on record over the past 1,300 years, and 11 of the last 12 years have been the hottest of those 50 years. So things are exponentially increasing in temperature. In the last century, there's only about a 0.6 degrees Celsius increase in global air temperature. However, the IPCC predicts that in the next century, the temperatures will increase by 2.5 degrees Celsius, a very large change. In the last 10 years alone, there were a 40% volume loss to polar ice coverage, and the sea level has increased over the last 15 years by 3.1 millimeters each year. We can see that in the chart to the right, the global average surface temperature, we can see that trend. That's the first thing up there on the top there. And the global average sea level, you can see, is also increasing. The first direct health implication are extreme heat events. The mean climate change temperature, of course, is quite slow, so 2.5 degrees Celsius over the next 100 years is a slow, gradual increase. However, those effects are not distributed equally over the course of a year. There's going to be kind of more wild fluctuations, and extreme ranges of temperatures are going to be increased. There's going to be increased frequency of extreme heat events, particularly in urban centers where there's the urban sprawl, the concrete jungle rather. Models project that there are going to be a 50% increase in the likelihood of extreme heat events in the near future, and it's cited that the Chicago heat wave of 1995 and the European heat wave of 2003 are some of the worst heat events in recent history. In fact, I'll read you something about it from an article here. So respectively for these two heat waves, 739 and 27,000 people died as a result of heat-related illnesses. Those who are bedridden, the elders, children, and urban poor present those particularly at risk. In Chicago, 3,300 people presented to the emergency departments for heat-related care. And it was estimated that in France alone, the costs were exceeded $8 billion American dollars to take care of those people during that heat wave. So pretty extensive. We can see a little chart here about heat-related deaths in 1985. That was the Chicago heat wave. Those who are at risk are pregnant women, the elderly down below. Also this gentleman who I think is maybe a worker. It says whether it's work or fun in the sun, he's drinking a glass of water, very good for him. Watch out for heat stress. So people who work out in the sun, maybe construction workers, those who work on roads are at great risk for heat stress. Let's talk about extreme weather events. It's expected that there's going to be increased frequency and severity, and some of you may already recognize that with the number of hurricanes and different storms happening, that we are already noticing this. It's attributed to warmer ambient temperatures and increasing humidity. It is raining less frequent, but more intense. So the number of rain storms are actually slightly decreasing, but when those storms happen, there is a massive amount of rain. So the actual total rainfall is actually increased. So 10 to 15% in the last 50 years. In the last 50 years, there's about a 10 to 15% increase in the amount of rain, even though the storms are actually slightly less frequent. That means that the storms are much more aggressive and there's more drought periods in between. Hurricane Katrina of 2005. This is a picture of a hurricane there, if you didn't know. And I wanted to read you something about that too. The direct death toll to Hurricane Katrina were estimated at almost 2,000 people, with thousands, many thousands more displaced from their homes. Direct accounts exist of suicides, homicides, and assaults occurring in the wake of the disaster. But of course, official statistics don't account for those that have suffered from poor sanitary conditions, and there have been casualties from that as well. It's been stated that all the waters around New Orleans were contaminated with feces, dead livestock, and chemicals leaching from flooded industrial facilities. So very dangerous and obviously very far-reaching. Let's talk about vector spread. The warm, wet conditions favor mosquito survival and reproduction, and because of that, it's expected that malaria is increasing 2 to 5% annually. Or sorry, those individuals at risk, the population is increasing by 2 to 5% annually. Quite a significant amount, considering that is millions and millions of people in the world. Dengue fever and Japanese encephalitis rates are also on the rise because of increased vector spread. Here's a quick map of Europe. The little inset there, over there, is in 1995. It's a good picture of Italy there, showing where the Asian tiger mosquito was found. And just in 2012, we can see this larger map that the tiger mosquito is actually far-reaching where it was in 1995. Ozone depletion. Since 1970, there's been a documented 4% per decade decline in the ozone layer, and most of it, actually a significant amount of it, is noted over the polar regions. The ozone gets depleted because of a catalytic reaction between ozone, which is 3 oxygen molecules combined, and halogen atoms, mostly chlorine atoms, and those come from chlorofluorocarbons, oftentimes abbreviated. You can see in this little chart here, CFCs. For every 1% depletion in the stratospheric ozone, so just even a small amount, it's estimated that there's a 2.3% increase in non-melanoma skin cancers. Because melanoma is so rare, they have a hard time estimating exactly the increase in melanoma, although they predict an increase in melanoma as well. So the other non-melanoma being squamous cell and basal cell carcinomas. They also estimate that there's 3,400 additional annual cases of cataracts in the world for every 1% depletion in the stratospheric ozone. And increases in photokeratitis, which is snow blindness as well. The increased UVB radiation also decreases immunity, and it's been documented that the disease burden of tuberculosis and herpes simplex virus are increasing because of increased exposure to UVB radiation. Water pollution, this is going to be a larger section here. Weather changes have impacted the amount of water and the access to water for individuals. And the population growth also generates pressures on water supplies. The situation with water is just getting worse and worse. The current numbers are expected to increase, but currently there are 1.1 billion people without access to clean water and 2.6 billion people without access to sanitation. So water contamination, viruses, we'll talk about viruses, bacteria, and protozoa. We'll start with viruses. Waterborne viruses like echoviruses, hepatitis A and E, rotavirus and norovirus are the most common. They all cause nausea, vomiting, diarrhea, and abdominal cramps. Hepatitis can also cause a pretty significant fever. The others can too, but it's a significant fever, lethargy, and jaundice. And most of these gastroenteritis are self-limited. Usually people do okay. They're able to tolerate fluids eventually and survive. Polio, another virus, infects intestines and then the nervous system. And so the symptoms of polio that we probably recommend or probably remember are those that cause paralysis, people being in the iron lung machine and having trouble breathing because of respiratory muscle paralysis. There's a large vaccine campaign that's been going on for quite some time, trying to get children vaccinated against polio. It's still a problem in many developing countries. Bacteria, let's talk about cholera first. The bacteria is Vibrio cholerae. It's rare in populations with minimal standards of sanitation. So in the United States, we're pretty much never going to see cholera. It, however, is still quite a serious concern in countries that do not have very good sanitation. Outbreaks can cause severe, life-threatening dehydration. People will have these rice water stools where they'll just continually have this significant output and become dehydrated severely. If just simply by oral rehydration, 99% of people survive. But without access to oral rehydration, there's a 60% mortality. It's very significant, very high mortality. Another bacteria, Shigella. There's three different Shigella species that can cause dysentery. There's also some viruses, some protozoa, and other bacteria as well. Shigella being the most common, so that's kind of characterized here. Dysentery is basically diarrhea containing blood and mucus. It's very high infectivity. Shigella, even just 10 actually bacterions, so actually pieces of bacteria, 10 is just enough to infect an individual. It's often associated with humanitarian crises such as like refugee camps or military camps. And without treatment, there's 10 to 15% mortality. Shigella oftentimes is self-limited as long as people get oral rehydration, IV rehydration, and sometimes it's indicated for severe cases antibiotics. The next is typhoid. Salmonella typhi is the bacteria. Symptoms just start as gastroenteritis, but people can, as the bacteria crosses into the bloodstream, it will cause high fevers, a rash, headache, and interestingly and paradoxically, a low heart rate. There are about 22 million cases per year, and 200 deaths result from this. There are vaccines for typhoid as well. Usually that's offered to Western travelers to developing countries. Talking about parasites, protozoa, I'm sure you've all heard of Giardia. This is a very common protozoa that is in North American waterways as well as across the world. It's a very common parasite infection in the United States, oftentimes affecting classically hikers. There's also Cryptosporidium, also can affect hikers as well in the waterways of North America as well as around the world. Helminths, which are worms, the most common being schistosomiasis. It's caused by a free-swimming larvae that penetrate the skin. Once they penetrate the skin, they get into the bloodstream and then infiltrate the liver and the bladder. They lay eggs and cause a lot of inflammation, leading to organ damage. So people can go into liver failure as well as cause significant damage to bladders. And then lastly, scabies, another parasite that is spread in the water as well. Let's discuss toxins in drinking water. There are a few that we're going to talk about here. All of these are increasing because of basically chemical spillage from human production of these chemicals, and it just goes into the waterways, and people are affected by them. Arsenic leads to skin discoloration, some cancers of the skin, bladder, kidneys, and lungs, as well as vascular disease. Fluoride causes enamel, so tooth enamel staining and pitting. Lead poisoning causes developmental delay in children, as well as nervous system toxicity, anemia, and kidney damage. And there's different organic compounds like benzoin and toluene, which are carcinogenic, that get into the water as well. Let's talk about air pollution next. High particulate matter, or abbreviated as PM, is linked to myocardial infarctions, asthma, COPD. Really, any type of respiratory issues that people have can be exacerbated by people with high particulate matter in the air that we breathe in. The major components of particulate matter are, and especially the small particulate matter, are sulfates, nitrates, ammonia, sodium chloride, and carbon. One of the sulfates, sulfur dioxide. It's produced by burning fossil fuels. It's a respiratory tract irritant, resulting in cough, reactive airway disease. So people with asthma will have exacerbation. Same thing with COPD. And long exposures to sulfur dioxide can cause diminishing lung function. Nitrogen oxides are produced by combustion, so cars will produce a decent amount of nitrogen oxides, and it's similar. It causes a burning to the respiratory tract, less severe as sulfur dioxides, but still very irritating and can exacerbate asthma and COPD. Ozone, which of course is healthy in the stratosphere, down on kind of sea level, is very dangerous to humans. It's resulted from ozone down here is resulted from photochemical reactions with nitrogen oxides, as well as volatile organic carbons. It can cause immunosuppression, lung inflammation, and increased risk of cancer and heart disease. Soil pollution, there are acute pesticide exposure that is attributed to soil pollution. It's less common. Newer pesticides have a much safer profile. However, many of the developing countries still use quite dangerous chemicals, including organophosphates. High doses of organophosphates can basically cause what's called an acronym of sludge. Basically, you can have lacrimation, diarrhea, bronchorrhea, and people can get quite sick from organophosphates. The toxidrome is anticholinergic, is what organophosphates cause. Chronic pesticide exposure is also linked to neurologic symptoms such as Parkinson's disease, as well as diabetes and leukemia. Soil bioaccumulation, DDT, as well as mercury, can bioaccumulate through chains, kind of the food chain. So in the waterways, it's kind of low levels. We'll get into smaller organisms, which will be eaten by larger organisms and end up going up the food chain and will accumulate. So the larger animals, whether it's eagles for DDT, mercury causes damage to fish or to large sea mammals, as well as to humans, will accumulate as it goes up and cause significant damage to significant disease. Oh, that was it. Soil pollution. I was hoping, so not too bad. I was hoping to show you a video really quickly from Jon Stewart. I do love Jon Stewart. I think it's quite fantastic. Let me see what I can find here. Here he is. Good old Jon Stewart. Let's just play this. It started already through the burn notice. I'll be quiet.
Phenomenon pretty much everywhere. Here's why you need the march. It's accepted pretty much everywhere, but there's one place called the United States House of Representatives Committee on Science, Space, and Technology. This is true. Last week they held a hearing that they apparently recorded in 1971. I guess that's the technology part of the committee name, on President Obama's plan to shrink carbon emissions 30% by 2030. The hearing's Sisyphus, Presidential Science Advisor John Holdren, charged with the impossible task of pushing 1 million pounds of idiot up a mountain. Of course, like any avalanche, it began rather innocuously. Texas Republican Steve Stockman.
The lead scientist at NASA said this. He said that what ended the ice age was global wobbling. Is the wobbling of the Earth included in any of your modelings? And the answer was no. When you have a model and you say we're going to leave out the most important impact of that model out of our theory and not talk about global wobbling, how can you make projections?
What's up, scientists? Global wobbling, bitches? He sees your so-called global warming and raises you a global wobbling. Explain that, Dr. Whitehouse.
Global wobbling, which refers to changes in the Earth's tilt and orbit, takes place on characteristic timescales of 22,000 years, 44,000 years, and 100,000 years. It is very slow. Global wobbling is a tiny effect on the timescale of 100 years in which we try to run these models.
I didn't know we'd be talking to an actual scientist. All right, Holdren, you aced the wobble warming. Riddle me this.
At what point a level of CO2 does CO2 become damaging? At what level does it become harmful to human beings?
Boom! How can CO2 levels be dangerous when I can still breathe?
Vice Chairman Rohrabacher, I always enjoy my interactions with you.
Much in the way one enjoys playing peekaboo with a baby, or perhaps teasing a cat with a laser pointer.
I have to say with respect, that's a red herring. We are not interested in carbon dioxide concentrations because of their direct effect on human health. We're interested in them because their effect on the world's climate, and climate change has
So
effects
it's a red
on human
herring.
health.
Well, then let me again, why can we still breathe? That's what I'm asking. I mean, you can hear me, right? We're breathing. And it got more amazing as it went. Indiana's Larry Bouchon.
It's not about affecting the global temperature and climate change. There's public comments out there that question has been asked and answered saying no.
Now, you should look at the scientific literature rather than the public comments.
With all due respect, Representative Bouchon, I suggest you get the Journal of Applied Meteorology and Climatology as opposed to the YouTube comment feed of Obama Lies 1776. But here's where Bouchon gives away the game.
Of all the climatologists whose career depends on the climate changing to keep themselves publishing articles, yes, I could read that, but I don't believe it.
I do not believe the scientists because it is their profession, not their hobby. Well, since we're talking about the influence money might have on climate change opinion, it turns out Representative Bouchon's three biggest campaign donors are Murray Energy, Koch Enterprises, and Peabody Energy. And trust me, those three well-funded companies would love to disprove climate change to the satisfaction of the scientific community at large. So if scientists could be bought, these motherfuckers would have already made it rain in Nerd Town. Trust me. And again, I cannot stress this enough. This is the House of Representatives Committee on Science, Space, and Technology.
How long will it take for the sea level to rise 2 feet? I mean, think about it. If your ice cube melts in your glass, it doesn't overflow. It's displacement. I mean, this is some of the things that they're talking about mathematically and scientifically don't make sense.
Are you kidding me? Are you kidding me? I don't even know. I don't even know what to do with that. How far back to the elementary school core curriculum do we have to go to get someone on the House Committee on Science, Space, and Technology caught up? Do we have to break out the paper mache and the baking soda so you can make a volcano? Is that what we have to do? Is that how basic the science class was when you went, I don't need to know this anymore? I mean, for God's sakes, look, here, look. Here's a glass of ice water. Hey, that ice isn't making the water overflow because it's already in the water. But imagine there's a whole bunch of other ice that's not in the water. It's on the land. You know, the part where the water isn't. And then when temperatures rise and the land ice melts enough to fall in, oh, it's everywhere! It's everywhere! Do you understand?
All right. Oh, thank you, Jon Stewart. You are quite fantastic. All right. Let's see. Do we have any more slides here? Oh no, questions. We can answer some questions on Thursday, which is shit. Oh crap. On Thursday at 1:30 Mountain Standard Time. I'll see you guys then. I'm looking forward to it. Thanks, guys.